Welcome to part 2 of the Royal Society of Chemistry Atomic Spectroscopy Group's introductory video on sample analysis. This step-by-step guide will demonstrate how to prepare a biological material for analysis, in this case, salmon. The first step is to prepare the fresh sample for a freeze-drying process. Freeze-drying enables us to remove all of the water present at a very low temperature whilst maintaining the integrity of the sample. The sample is placed into a clean beaker using non-metallic utensils, then disaggregated to increase the surface area. The beaker is then covered with a suitable plastic film, sealed, and then placed in a freezer at less than -20 degrees centigrade until frozen. The frozen sample is placed into a freeze dryer, remembering to pierce the film to give a number of small holes. The beaker is placed inside and the lid is replaced. The venting valve is closed, allowing the chamber to be reduced in pressure to produce a vacuum. The temperature is also reduced to usually between -50 to -80 degrees centigrade. When the process of drying is complete, which can take up to 48 hours, the sample is removed and blended to produce a homogeneous material. Once ground to the right particle size, the sample is transferred to a suitable labelled and sealable container for storage. As shown in the Part 1 video, we now need to check the calibration of the balance. The analytical balance must be checked that its calibration is correct using certified weights of known mass. Here, a 10-gram weight is being used. While the checking process is being conducted, the digestion step can be started with the digestion vessels being pre-cleaned ready for use. In this case, we'll be using a sulfuric acid-based wet digestion method. The sample can now be weighed into a weigh boat. Here, about 0.5 grams is being collected. The exact weights before and after transfer to the clean, dry digestion tube gives us an accurate catch weight. The exact weights are recorded. In order to validate the method, a certified reference material of similar composition to the sample is used. In this case, dogfish liver tissue. This is also carefully weighed into a boat, and its catch weight is collected in the digestion vessel and accurately recorded. The next step is to digest the sample with concentrated sulfuric acid, which is handled in a fume cupboard. A calibrated pipette can be used for this process. A pre-digestion step is performed at room temperature to avoid any later violent reaction. After about 2 hours, the sample will have turned black. This can be placed in a heating block set at 250 to 300 degrees centigrade. Note the 3 replicate samples, a digestion blank, and the certified reference material digest. When white fumes are observed from the hot digests, concentrated nitric acid is carefully added dropwise to the vessels. Each drop produces a vigorous reaction with brown fumes. Progress can be monitored by loss of the black colour through to a yellow-brown when more drops of nitric acid are carefully added to complete the process. The time taken can vary from sample to sample and on the weight taken, but once complete, the solution is almost colourless. This digest is then cooled and quantitatively transferred into a volumetric flask, washing out the digestion vessel to ensure all has been transferred. Before we can prepare our calibration standards, we need to calibrate the pipettes. This is performed by using the weight of the water they dispense. We can now prepare our calibration standards using, in this case, single calibrant solutions of known concentration of the analytes of interest. Before making up to their marked volume, the acids used in the digestion are also added to match their concentration found in the sample digests. The flasks are then made up to the mark and mixed by inversion. Finally, the measurement step is performed. Here we're using an inductively coupled plasma optical emission spectrometer. To construct a calibration graph, that is the response of the instrument to the known standards, each of the calibrants are introduced and measured in ascending concentration. This instrumental technique is related to the emission-based flame tests you have probably performed in your studies, but here the intensity of emission is measured quantitatively using an alternative hot source. A straight-line calibration graph should be produced, and this is used to calculate the concentration of the analytes of interest from the sample's measured response.